Welcome to N is for Networking, where today we have a very special episode. We are going to read more, feedback that we've gotten from folks recently. We're going to cover a defense of OSPF multi-area deployments, as well as a request to discuss OSPF LSA types. We plan to walk through an IPsec transaction in the next episode. So if you're here for that, that's why you showed up today. Next time, I promise we're going to do the IPsec transaction stuff. We're going to walk through it. I am Ethan Banks with Holly Metlitsky, and together we explore key networking concepts. And I'm the guy with the gray in his beard. I've been doing this since the 90s, and Holly is in the unfortunate position of having to take what we network people have been building since the 90s and learn it all at once. So maybe you're in that situation too, where this huge imposing list of jargon and acronyms and concepts that make up a modern network are a lot to take in, and you're just trying to make it all make sense. Well, that is the point of this show. N is for Networking is all about it. We are here to help and hopefully entertain you a bit along the way. So follow and connect with Holly and I on LinkedIn or the Packet Pushers community Slack channel, which you can find at packetpushers.net/community. And we're glad you're here. Oh, Holly, so we got a couple of robust bits of feedback on our OSPF series. And the first one is from Hensley, where so just to review for people, you and I had talked about multi-area versus single area OSPF. And generally speaking, our take was what? That
in today's modern day and age, usually you don't need multiple areas, that it's okay to have everything in area 0.
And that's been my experience. That said, I definitely have done multi-area OSPF in the past, but I feel like, and I think what we argued for was that a lot of that was historical, where you really wanted to contain SPF calculations and so on. And so you didn't want to overburden a router CPU with having to do too much work if the network was changing a lot. Modern CPUs can handle a lot more. Keep things simple and put it all in area 0. But Hensley disagrees and had a lot of feedback for us with the way his network is deployed. So Holly, what did Hensley have to say?
Let me get into it. So hang in there, listener. It's a lengthy one. So Henny writes in to say, I don't mean for this to sound like a rant, but it is a rant, so I suppose it should. I wanted to comment on a single area OSPF comments from the first episode it was mentioned, but I was patient. But then it got worse. I can no longer hold it in. I must share my thoughts. So here are Henley's thoughts. I have a fairly small network and utilize multi-area OSPF. In fact, my network is comprised of mostly multi-layer switches, not routers. The topology is quite flat. The switches are at different buildings connected over L2 ISP network, with each having an interface in area 0. All SVIs on the switch are in the same area, but not area 0. This allows for summarization. Each building already had contiguous network assigned, so it makes sense to summarize. Additionally, if everything were in area 0, an SVI going down would cause OSPF to flood LSAs on a switch in a different part of the city that it doesn't need to.
Okay, true. I agree. Yeah.
So I also have some edge routers that have set up as stubs. I guess my point is my network is very small, but I use areas because that's what they were designed for. To me, it would be like sloppy writing, inefficient code. Just because computers have fast processors and loss of memory, I don't think we need to seek reasons to use the features because we just want to geek out. But when it makes sense, we certainly need to know them and use them appropriately. I'm still shocked that so many of Holly's customers, I'm going to pause there. I don't have that many customers. I haven't come across like hundreds of networks with OSPF. Just a caveat, but so many of Holly's customers are just putting everything in area 0. I'm certain it's just fine in many scenarios, but I'm concerned that you have never ran into it. It may be a lack of understanding of OSPF by the customer. It's very easy to put everything in area 0 because it works, even though it may not be the best decision. Maybe the inefficiencies aren't noticeable, or maybe they aren't being looked at. I will concede that if people are using VXLAN to extend L2 networks, then summarizing makes less sense, in which case OSPF networks are perhaps much smaller. It's a very different architecture, But for traditional L2 networks, summarization just makes sense. And for that, you need areas. End rant. Post rant. All this is important to know. I had a stub area that one day needed to connect to another autonomous system because reasons. Never imagined that would happen, but it did. Answer, NSSA. Not so stubby area.
Okay, so there was a lot there. So you just read through all that, Holly. Thank you. And did any of his comments stand out to you particularly?
I actually really enjoyed this actually, because it's exactly what I've been looking for. Somebody who's doing the thing where we're like, oh, we don't need area zero. And he's like, well, actually, here it is. Here's the exact use case. It makes sense. I want things summarized. He's got remote sites in different locations. To me, yes, that seems like a great use case for it.
And Hensley, I'm on your side too. I don't disagree with what you've deployed here. However, so I kept my own actually version of this. So on the one hand, is one key thing you said was about contiguous networks. Each building where you're interconnecting all these different buildings have a contiguous series of networks assigned, meaning you've got some block of networks that follow numerically one on another so that you can summarize them into a larger block and just announce that summarized block from whatever the area is that they're in into area zero, and then and share that into the other areas. Great. Got it. That does allow for summarization. You're exactly right. You got to do it at an area border router. You can't summarize within an area, which we talked about in our OSPF series, Holly, where because every OSPF router has to have the same exact same link state database in order for them to do their computations identically. You can't summarize within an area. You can only summarize between areas. So yeah, and Hensley, as you're saying, that exactly requires a multi-area if you want to summarize. And when you have those contiguous networks assigned, because you're lucky enough to have an IP address plan where you could do that. A lot of companies, that doesn't work out that way. You do, awesome. And so it just makes sense to summarize. Fair point. Okay. And I have been in those environments as well, it was in a metro Ethernet environment where we had fiber running across the city to various campuses, and we did that. We had multi-area, and we summarized on the boundaries just like you did. They were quite a bit bigger of a network than what you're describing. Not a huge number of routers and switches, but supporting tens of thousands of people in that environment. Okay, so here's the actually part. When you make any sort of a network design decision, there are trade-offs. You are making choices. And when you're keeping all of your OSPF routers in area zero, you can't summarize routes. That is true. That's a trade-off. On the other hand, you've implemented a design that means you've got to re-engineer redundancy for inter-area routing. What happens now if you had one area, you could just mesh things any which way and you'd have your redundancy. Now you're in a situation where it sounds like it's metro, and in my experience with long haul metro environments, you only got so much fiber. You got the fiber you got. It's not like a data center where you can put a bunch of different links in here and in there and wherever you want because you own the facility. In metro, you've got the fiber you've got. And even if you have redundant fiber, it's probably going down the same path. And so your redundancy is kind of, if you're trying to protect against a fiber break. If you have one area, you could do it though. You could do whatever you wanted and have that redundancy. If you have multi-area, you have to create multiple area border routers, and the ability you have to have redundant links from each area into area zero, which you would really want, is compromised. So that's a trade-off. That's a trade-off. That's just another thing you got to consider. In your case, it probably doesn't matter because it's metro. Another point here I'll make is, generally speaking, multi-area OSPF adds design complexity when compared to single area. And again, you got a small network, but you're saying, but this is again another trade-off. when you add multi-area, now there's different things to be thinking about and different things to consider. Single area is a simpler design. And so I would say there are some people, like you say, they just probably don't know OSPF very well, so they just throw everything into area 0 and call it good. But there's plenty of people who are making a conscious decision of like, I'd rather not have the design complexity of multi-area. And that is an intentional decision they're making because they're looking at those trade-offs. So my friend Russ White, he would say, if you don't see a trade-off, you haven't thought about it hard enough, because there's always some choice you're making when you go like you did, multi-area versus single area in this case. And so Holly, I don't know how much you run into this, but when I'm looking for those trade-offs, one of the ways I like to get those trade-offs to come to the surface, because sometimes it's not obvious, like design A or design B. I don't know. They both look kind of the same. Well, I'll think about, okay, well, in this design, if this failure happens, this link goes down, this router crashes, what happens? And a lot of times thinking through that process will surface those trade-offs. I mean, is that an exercise you go through with customers?
Occasionally. I haven't run into a lot of like design situations where my opinion is required, I guess. But there have definitely been a couple where I'm like, I don't know if this, looking at this and what I would suggest, what is the reason that we're going with one design over another?
Mm-hmm. Yeah. So to me, that's the big takeaway then is those trade-offs though. There's always a trade-off, always some kind of a trade-off you're making when you're looking at one versus another. And Hensley, there's trade-offs here. I will say that we network engineers are people of a certain type, and there's a bit of OCD that goes into some of this stuff. So one of the things you highlighted was, I don't want every time there's some kind of a network change for there to be an SPF calculation that has to happen on all these other routers. Why? That shouldn't have to happen. That device is in a different part of the city. Right. But it doesn't actually matter in the modern scenario from that CPU perspective. It matters from a pure cleanliness perspective and so on. Absolutely. Summarization. You have to summarize on an area border router, so you need multi-area, but does summarization actually matter? When you have tens of thousands or hundreds of thousands of routes, it might matter. It might be a big deal. Does it actually matter when you've only got, and you said you have a small network, when you've got tens or hundreds of routes? No, not at all. It just looks cleaner and it appeals to our network engineer OCD, that kind of thing that we love. It's like, oh, it's so neat and tidy and I'm so happy. Yes. But does it make a practical difference in the operation of the network if you have one versus the other? Or does it just make your brain happy? And those are questions where you can get really pedantic about some of these details that, practically speaking, don't always matter. They matter to us because we're us and we're built a certain way, and that's why we're good at network engineering. But just, know the difference and be willing to, make the trade-off one way or the other. As I said at the top, I'm happy with your design. If it works for you, works great. No problem. Do you have to do it the way you're doing it? No, you don't. You said small. I don't know what small means. I'm assuming you've got, 10 routers or maybe 50 routers or something like that. It's not a big network. You could definitely do it as an area 0 if you chose to. You chose to do multi-area. I don't fault you for that, especially with the summarization thing, because it does make my inner nerd happy too that you're doing that. I mean, I get it.
Yeah, when I read this, I'm like, this sounds so neat and tidy.
Yes.
And lean. And
yep. It sounds lovely.
Yeah, exactly. There's one thing that I do want to mention that maybe we should just clarify. And we'll discuss this more in depth in probably a later episode, but there's some acronyms in here that we've never mentioned. And the one is SVI, which I think is a Cisco term for
Switch
Juniper's
virtual interface.
IRB, integrated routing and bridging.
Bridging, yeah, could well be the same. Yeah. So that's that is, you've got Hensley mentioned multi-layer switches. Yes. So on a multi-layer switch, we had talked in an earlier episode about switches being layer 2 versus layer 3, and what does that mean? And this means, when he says multi-layer switch, it is a switch that can route. It is a switch that is a layer 3 switch. And on layer 3 switches in the Cisco world, they call them SVIs, where you have you create a layer 2 VLAN, And then you add a layer 3 interface that is for that VLAN. So you can use that switch as a gateway and route your packets from that VLAN into a different VLAN. You build an SVI, a switched virtual interface, to accomplish that. So, yep, that's one. He also said, did he say POP or did I say POP? I don't know. But point of presence, where you hook in via your ISP to different parts of the network. They will present a POP somewhere in a city or a town where they connect your network to their network. You're going to talk to some POP, some point of presence that they have in your geographic area. I think I might have mentioned that along the way. There's another term. Did we miss any other ones, Holly?
I think SVI was the only one that stood out to me. Again, maybe just also because I don't deal with Cisco terminology very often, but that one I do know because people usually refer to them as SVIs.
Yeah, it's a very common one. Okay, we have another OSPF question that we want to dig into then. And this wasn't a well, actually, so much, but this is by Brian, a friend of mine, someone I've met in real life a few times. And I guess you know about him too, Holly.
Yes, through Juniper, and I know his name. He floats around.
Okay, we'll just leave it at Brian, but he's someone that we've run into a little bit. Okay, so Brian says what about LSA types?
So Brian says that he listened to our episode 38 about OSPF.
36.
Sometimes
this is 38, I think. Yeah.
I was going to say, I don't know where I got 38 from, but it clearly says 36. Anyways, he listened to episode 36 about OSPF. And he says, I have to admit that LSA types and area types are something I memorized for cert exams. Me too, Ryan. And then promptly forgot. Me too. So I was excited to listen to the episode to relearn these concepts. However, I was saddened to find that you never actually explained the LSA types, just the area types. While I think I finally have solidified in my brain the difference between NSSA, TNSSA, etc., I still couldn't tell what type 2 LSA is. Perhaps a follow-up episode that covers this?
Yes. Okay. And that's fair. So we didn't, and Holly, you can blame that on me because
I think I did mention it.
Yeah. To me, getting into the details of LSA types and a lot of the topics we get into on this show, it's like, well, where do we draw the line? Because there's so much we could get into, but this is meant to be a basics and a fundamentals show. Is it important to know LSA types, as you and Brian and me have all, and lots of us that have gone through cert exams have all experienced? You figure out the LSA types, you kind of understand what they're there for, and then you forget them because in the daily practice of operating an OSPF network, it's the kind of detail you could look up if you really needed to, but generally speaking, you don't think about it. It doesn't matter a lot. And so I'm always battling, well, do we go into that or not? Is it just going to confuse people for whom we're trying to help understand the fundamentals of a protocol or whatever it is? And does, in this case, talking about LSA types help? Well, I don't know. I would argue not really, depending on where you're at. If you're studying for a cert exam, then, I mean, Holly, you've been through a bunch. Did LSA types probably came up, huh?
Yeah, and I would say that I learned them before I understood the fundamentals of OSPF areas. I think I truly understood areas when we recorded our areas episode. And then I was like, oh, now I understand what these LSA types actually have a purpose for. Where before, I was like, I know the LSA types, this is for this is for that. But fundamentally, I didn't actually understand their purpose. So I think us going into the LSAs, once you understand the fundamentals of areas, if you know the LSA types, it's much more logical.
That was how I felt about it too.
Yeah, but you really have to have that fundamental understanding first, which I didn't have. I did it backwards for a change.
And a lot of cert guides are like that. They kind of throw at you the concepts of areas and LSA types and the link state database. It all kind of comes at you at once, or it feels like it does if it's all new information that you're trying to read through the chapters. And it can be difficult to figure out how it all fits together. But okay, as you said, once you get your brain around the different area types, OSPF area types, and know what they're for, then the link state advertisements that originate from different area types for different reasons make more sense. You kind of know how the Tetris pieces are supposed to fit together. So, okay. So before we talk about different types, we're going to talk about, we'll talk about types 1, 2, 3, 4, 5, and 7. Since those are the most common ones, we're going to go, Brian, you got your wish. We're going to do it. We're going through all of them, all the ones that you hit most commonly. But before we do that, what are link state advertisements for? What do we do? Can you put them in their place in the world of OSPF, Holly?
So that's how our OSPF routers are going to send certain updates and information between each other and share certain routes and other things.
Yeah. The link state advertisements have, as the routers do exactly what you said, send LSAs to one another. This is the data that they use to build the network graph, or also known as the network topology, the OSPF link state database. All of this stuff is going together. I think from a math perspective, we would call it a graph, right? Isn't that, because you said the Dijkstra's algorithm that computes SPF. Wouldn't that be a graph? Is that right? Or is that wrong? You did the study on that. If I'm wrong,
I don't know if we ever referred to it as a graph specifically, but it's like some type of mapping, I'd say.
So let's just stick with network topology then. The link state advertisements have the information in them so that each OSPF router can build out the network topology, and they store all that information in their link state database, which, as we've said, has to be identical from router to router within an OSPF area. LSAs are the things that get flooded when something on the OSPF network changes. A network gets added or it's withdrawn for whatever reason. A link goes up or comes down. Those will drive LSAs to get flooded throughout an area. The thing that actually Hensley earlier was saying, hey, without multi-area, you're going to have a lot more flooding going on, and routers seeing flood events that they didn't need to see because it doesn't affect them in this part of the city. LSAs are also making sure that the link state databases are identical. It's not that you hope they're identical. LSAs have features so that we know all the link state databases are indeed identical across all routers in an area. LSAs are flooded reliably because there's acknowledgement packets that come back. One router sends the LSA out, and the another router says, I got it. And so it knows, okay, my LSA was received by the neighbor I sent it to. There are also sequence numbers attached to a link state advertisement that increment. So you can tell that a LSA is newer than a previous one. Oh, this is an update to an LSA I saw about this information earlier. And therefore the one I have is old information. The sequence number tells me it's newer. And there are checksums that are used to validate that the packet didn't get corrupted or changed along the way. So we have all of these components and elements to a link state advertisement that are used to make sure that every router in that OSPF area has the identical link state database. Okay, I didn't mean to beat that to death, but
one comment before we jump into the different types, and it's funny because I don't know why I mentioned OSPF LSAs, I think yesterday, but to an account manager that I work with, and he asked me, like, what are OSPF LSAs? Like, you throwing acronyms at me. And it actually made me think of something. Like, we call them LSAs because that's specific to OSPF, but really it's just some type of like control message, if you want to call it that. And throughout every different protocol, we have these messages that go out to the network, and it's just OSPF calls them LSAs because of what they do. But because we love to create new acronyms and to create new terms, there's actually, like, I related them kind of to BPDUs. Like, I know that's a term that...
Yeah. No, you're exactly right.
It's the same, kind of the same thing, contains different information, but just specific to OSPF. And that was helpful for me as well, because when I first heard about LSAs, it was just like an acronym for OSPF. But now that I can fit more pieces together, I'm like, yes, it's an LSA for OSPF, but it's got a very similar function as other things like BPDUs have for other protocols.
Yeah, no, I love that you said control message. BPD used for spanning tree.
Yep.
BGP has NLRIs. And I'm sure if I thought about it, I could come up with some other ones. But yeah, you're exactly right. It's the format of the message that flows between the two different devices that are speaking this language. You've got to format, you got to marshal that data in some way. And send it back and forth. And link state advertisements are what came up for OSPF. And as you said, there's lots of other messages that flow between devices that are members of other protocols. So exactly right. Okay, so type 1 OSPF LSA, that is the router LSA. Basically, hi, I'm an OSPF router, and here are all the interfaces I have, and here are the networks that they are attached to, routes. Here's links I have to other OSPF routers via my interfaces, along with all the costs and my neighbors across all those links. So a type 1 router LSA has a lot of information in it. And it's like I think of it as the fundamental building block to start building your topology within an area. It's got a router and all the interfaces and links, which... Think about that for a second, Holly. Do you think you can figure out because this took me a second. I had to wait a minute. What's the difference between an interface and a link? I had to do a little bit of digging. Do you think you know what the difference between an interface and a link is?
Well, if I think about it, you could have one interface that possibly has multiple links, but not going to have one link with multiple interfaces.
Yeah, the interface is the physical thing.
Yes.
Like it's the gigabit 000 or whatever it is that it's got an IP address and a link, a OSPF network type and whatever else has been assigned to it. And if you're on Ethernet, there could be 5 other routers that you're talking to across that, and you have links to each of them through that single interface. And so that's the distinction there. Yeah. So again, we're talking about type 1, the router LSA. Hi, I'm me. I'm a member of this OSPF network, and here's all the links I have. Here's my neighbors across those links, etc. And as you get LSAs from all the other routers within your area, all the other type 1s, all the other router LSAs, it's like a puzzle. You can put all the bits and pieces together. Okay, he said he had... this first router said he had a connection to this other router over here. I got an LSA from that other router, and yeah, that information matches up. And with that information, each router begins adding those LSAs to its link state database and then figuring out the topology of the network. And therefore, we end up with each router having an identical picture, an identical topology that it's computed based on all that information that comes through. This would be why, in part, your router ID is so important. If you have multiple routers in an OSPF area with the same router ID, that's a bad situation, because now your OSPF process is going to get confused. Well, wait a minute. This and that can't both be the same router because they wouldn't fit together. The puzzle pieces don't fit anymore if you have 2 routers claiming to be the same router ID. Have you run into that before, the duplicate router ID problem?
I mean, I've read about it. Luckily, I haven't had that situation, but
production environments don't last long when that happens. Because you've got 2 routers that are actually physically different routers with different type 1 LSAs they're sending out the door, but claiming to be the same router, which just confuses the heck out of the OSPF processes trying to build the network topology. Yeah. Okay, so that's a type 1. That's that fundamental building block you're going to have there, the router LSA.
And if we think about our different areas, because I'd like to relate this back to areas, because that's what made sense to me. Everybody's got to send a type 1 LSA, no matter what area you're in. How else are the other routers going to know about you? So,
exactly right. You're right. Every area will, every router in every area will send type 1s. Yes, we are not limited by area or area type as far as that goes. Okay. Type 2, network LSAs. This is a bit of an odd one, but on broadcast networks, as in multi-access networks, something like Ethernet, not a point-to-point network, but on broadcast networks, the designated router, which you remember we talked about designated routers, the designated router will use a Type 2 LSA to tell all routers on the segment about each other. So, do you remember the job of a designated router?
Yes, kind of. But the designated router, I'd like to think of as like the management router. That's like the keeper of all the secrets. So when something happens, the designated router is where it's going to send the updates from.
Yeah, it's in sort of like a BGP route reflector, rather than having a full mesh of OSPF routers on an Ethernet segment. Like we were saying, you could have 5 or more OSPF routers on a common Ethernet segment that could all see and discover each other, rather than having a full mesh of OSPF routers building neighbor relationships, everybody to everybody else. The designated router simplifies that. Hey, we're going to elect one of us to be the one that tells everybody else what's happening on this segment. And when you join a broadcast segment like Ethernet, and an election will occur, and a designated router will be selected, and then the designated router's job is, all of you tell me about your LSAs, and I'll tell everybody else what your LSAs are. The Type 2 LSA is the designated router telling everyone else about the other routers on the segment. So you know who else is out there without you having to form a direct neighbor relationship. I don't believe that is, that is not the designated router telling everybody else about everybody else's LSAs. It's about everybody else on the segment that's there. It's kind of a unique one, if I understand that correctly.
That was a lot of everybody else, and I think that confused me.
Oh no. Okay. So ask a question, and I'll see if I can clarify. Because if I confused you, I confused somebody else.
I was gonna say, because the way that you phrasing it makes it sound like only the designated router sends Type 2 LSAs.
That is true. The designated router, is my understanding, is the only one that is going to send Type 2 LSAs.
Okay. Then that makes sense.
Okay. So, and then the everybody else is who's not a designated router.
Yes.
That's everyone else. So we got the designated router as your speaker on that segment, and everybody else is not the designated router, is what I'm getting at.
I guess that wouldn't make sense, because the designated router would send it to everybody else. You wouldn't need the speakers to send that out to continue the messaging. Okay.
Okay. Yeah. I see you guys. I see the wheels turning.
So my issue is that, like, I know that you can have Type 2 LSAs coming out of every type of area.
Yes, that is possible. Yes.
Okay. Why?
I see wheels still turning.
In each area, you will have your own DF, your own designated router.
Well, not in each area. That's segment specific.
Exactly. So you won't, but only your designated router sends Type 2 LSAs. I don't know if I'm going down.
You could have multiple designated routers in an area. That is possible, because you could have multiple different segments, all depending on what your network topology looks like. You could also have more than one area border router, but that's very different. That's a whole different thing, a whole different function from what a designated router does. A designated router is on a broadcast segment and fulfills a specific role on that segment. But you could have multiple segments within your OSPF network within an area that require a designated router. So you could have a whole bunch of different designated routers, and they would all generate Type 2 LSAs. And just reading some text here, some copy describing this. Hang on, scrolling. Looking at definitive sources. Type 2 LSAs are generated by the designated router to represent the multi-access network segment itself. Again, this represents networks that routers are directly attached to. The multi-access network segment itself. So it's unique to that, that one segment, that particular network. And the designated router is generating those. Feels like a lab exercise to actually look at what's in there.
Yeah.
As distinct from say a type 1. Okay. So I don't know that we did that justice exactly.
I think so. I understand. Like, pretty much, I think the fundamentals thing is if you had to see type 2 LSA go out, it's coming from your designated router. It's going to have some sort of update about that segment, and there you go. That's its function.
Okay.
You can leave it at that.
And you will have, and you can have type 2 network LSAs in any area that is possible. Yeah.
Yes.
Okay, Holly. So I don't know how well we did type 2s here, but just to summarize it has to do with describing the network, that broadcast segment that's got a designated router, maybe a backup designated router on it, and it's got information about that in there to let the other routers in that segment know who the DR and the BDR are, and what the subnet is that everybody lives on. It's unique to that specific situation. So kind of it's almost like a special case, type 2, but they're really common because we have DRs and BDRs out there all the time, since so often we're dealing with broadcast segments. Okay, you ready to try type 3 if we didn't blow that up too badly?
Yeah.
Okay. Okay. I don't know.
This is Brian. Brian requested this, so this
Brian, we're doing
well
our best
Brian.
for you. It should be, we should do better, but we're okay. So type 3 are summary LSAs, and summary LSAs are generated by area border routers, and the ABRs are generating a type 3 summary LSA to announce inter-area routes. That is, hey, area 1, here's some routes I know about that came in from area 0. And, for example, and then announces those routes in as a type 3. And so a type 3, it's like, well, wouldn't that be maybe a type 1? Well, yeah, it's kind of like a type 1. But when you're in between areas, there's things you don't need to know. Within an area, you need to know all about the topology and all kinds of things that are going on. So we don't care going in between those areas, again, what the topology details are. So you've just got less information. So type 3s, again, generated by the area border routers, and you will see type 3s in many different kinds of areas. So like a stub area, you'll get some type 3s. A stub area doesn't receive external routes. If you remember what a stub area is all about, you can still get information about all the other networks within the OSPF domain, an autonomous system, if you will, but not routes outside of the autonomous system that might have been redistributed from another routing protocol, for example, as an external route. Those won't make it into a stub area, but you will see those summary LSAs with a stub area, but not a totally stub area. Totally stub area, then you would not see type 3 summary LSAs being sent into a totally stubby area, because that's the difference between a totally stubby area and a stub area. You're not a totally stubby area. You're down to just a default route is all that's announced from area 0 into that summary area.
Yes.
So that's a type 3 summary LSA. Does that make sense?
Yeah, that definitely makes sense. And I think that's where we discuss like the naming of those areas. And it's, to me, I like to think of it, if it says totally in front of it, you only receiving that default route and you're not getting that type 3 LSA. Yeah.
One more detail about the summary LSA to wrap this one up. There is, OSPF's got cost, right? We count cost per link in between OSPF routers, and the accumulated cost is the total cost to get from where you are to the destination route you're trying to reach. You do have cost included from the ABR to the destination route, so that when the ABR advertises the type 3, it'll know the total cost to get from itself as the ABR to the destination route. And we'll pass that along within the type 3. And so you will, as a router in a different area, know the total cost to get from you through the ABR to the destination route. Cost is accumulated. That's one of the things that is shared in the summary LSI, even though we don't have all the topology information. So, all right, a couple more here. Type 4, that is an ASBR summary LSA. So it's giving us a hint here. It's going to be like a type 3, but it's different. It's an autonomous system boundary router. So what's the difference between an ABR, an area border router, and an ASBR, autonomous system boundary router?
So an area border router sits between two OSPF areas, and your ASBR, as the name indicates, sits between two autonomous systems. So that will likely deal with routes that are external from that specific OSPF autonomous system.
Yeah, exactly. So the type 4 then is like a type 3, but instead it's hey everybody, this is where an autonomous system boundary router is attached to the OSPF autonomous system. So if you want to get to this autonomous system boundary router, probably so you can get to an external route that it's announcing, here it is. So it's the way to get from you to the ASBR. And closely associated with this then would be a type 5, which is an external LSA, a link state advertisement of a route that is external to the OSPF system. It's being redistributed in from a different autonomous system. So a type 5 external LSA would be hey, everybody, here's a route that we heard about from outside of the OSPF domain, and here's the router ID of the ASBR that originated it, so you know where to go to get to that external destination. And how would we know how to get to that router ID of the ASBR? Because of the Type 4 ASBR summary LSA that gets announced. So Type 4s and Type 5s tend to go hand in hand. Not only do you need to know the destination network, you need to know how to get to the router that originated that external route for you, the ASBR that originated it. So Type 5s, the external routes, and Type 4s, the ASBR that originated those external routes. Okay, how's that sound?
Yeah, and would not include, I want to call them stub areas, but because we mentioned those are like a cul-de-sac, so you've got nothing external linked to those areas.
We would have a different area type if we had external routes being injected. That would be a not so stubby area, an NSSA, which leads us to a Type 7. The last one that we're going to talk about here in this list, a Type 7 LSA, that is a not so stubby area external LSA. It's the same as a Type 5. It's a destination, a route that is external to the OSPF autonomous system. But it was originated in a not so stubby area. So instead of it being a Type 5, it is a unique type. It's a Type 7. And when that Type 7 hits the area border router, the area border router is going to announce it as a Type 5. It's going to convert it to a Type 5 and then send it along.
Never quite understood like the purpose of that. But like I understand what it is, but why not just like why do we need to differentiate that it's coming from a not so stubby area and then convert it back to the Type 5? But it's an easy one to remember because if you see Type 7, you know it's coming from a not so stubby area.
So a Type 5, which is for an external route, isn't allowed in a stub area because that's the point of a stub area. There's nowhere else to go. And so you end up with this like, well, wait a minute, I've got an external route in my not so stubby area, but a stub area isn't allowed to have Type 5s, so I can't create Type 5s. And so they created another type, the Type 7. So just so that you can share that information internally, you can't have an external Type 5 because those are the rules. So we have this Type 7, which is unique for the not so stubby area, but then the rest of the network doesn't care about Type 7s. It could be happy to take those as Type 5. So the area border router converts it to a Type 5. So it's like this weird little OSPF thing. It's just an odd, it's an odd thing. It's an odd deal, because in a stub area, we couldn't take type 5s and advertise them into that area because it's a stub area. So you can't have an ASBR inside in the stub area and then originate type 5s. OSPF doesn't want that to happen. So we end up with this weird type 7 one-off for this very unique situation, which Henley has apparently.
Yes,
Hensley. Yeah, he mentioned that early on in our first question in this. Okay, so now we've talked about type 1s, type 2s, type 3s, 4s, 5s, and 7s. Those are the most common types that you're going to see in your OSPF V2 deployment IPv4. Now, there are other types. So like, hey, well, what about types 6? And what about other types? Yeah, there's several other OSPF types as well. When you are doing multicast, when you are doing OSPF version 3, when you are using OSPF TLV, something that we haven't talked about that came much later in OSPF's development, you might run into some of these. Some of them are more experimental, and there are types that never really were used. As far as I know, there are 11 total types, and we didn't talk about types 6, 8 through 11, and we're going to skip them for this discussion. For OSPF V2, which is what we've been focused on today, those are the types that you're likely to run into, in my experience. And, Holly, in your training, as you've been digging through stuff, have you run into any of the other types other than the ones we just discussed?
No, I got pretty much the same caveat in all of my training was, here's types 1 through 5 and 7. Yes, there are others. Don't worry about them. Okay.
Whew. All right. Now we've gotten to the end of this discussion. Now, because through the magic of editing, audience, and in the spirit of transparency, Holly and I went back and forth, confused ourselves into the wow, and then re-referenced a bunch of sources to make sure we were getting the story right. So hopefully this doesn't result in another, well, actually, where we got something wrong, because we were looking at both Juniper and Cisco authoritative sources to make sure we got the details right. And hopefully we did, and we didn't confuse you on
we
those.
did get a well, actually, recently that asked us to answer a question during the episode. So today we've actually resolved 3 well, actuallys in the background.
Yeah, that was Brian's fault too. Thanks, Brian. But we did that, and that ended up derailing us. We actually had to check our calendars to make sure we had enough time, because we ended up chewing up another 25 minutes of looking up answers before we got in. So those of you listening, appreciate your editors as well. We have wonderful editors that take time to chop these shows up for us and make them sound as smooth as they can. And a lot of that happens on shows like this. Well, anyway, thank you for listening to N is for Networking, or watching if you're on YouTube. Send us your comments, your love, your well actuallys to packetpushers.net/follow-up, or join the community Slack group that we have at packetpushers.net/community. And you can also communicate with Holly and I with your well actuallys at the N is for Networking -pod channel that's in that Slack group. We get lots of feedback from all of you. We love it. Send more. Thank you. Even if it makes us stop and scratch our heads and wait, and then in my case sweat. Okay, yeah, it's I'm supposed to know, right? Please like, subscribe, tell your friends. N is for Networking is climbing the ranks of the many Packet Pushers podcast series. Holly and I want this show to be number 1 eventually. That's our goal. So help us out by letting the world know about this show. We are everywhere that you get your podcasts, including YouTube, where you can see Holly and me chatting with each other, if that's the way you'd like to experience this show. Until next week, just remember, networking isn't hard. Other people figured it out, even us. So you can too.